Okay, lesson 80, transformations. Can everyone say transformations?
Transformation.
Kind of reminds me of Transformers or something. Yeah, they're changing. Now, transformations, some of them stay congruent. And I'm pretty sure we've been using the congruent word throughout the term. I even think we may have written the definition at one time. Just means exactly the same in every way. So it has the same size and same shape. So some transformations will stay congruent. They can be turned and still be congruent. Uh-oh. That's a congruent symbol. We have seen this, right? No? Yeah. Okay. So you can take a shape and turn it, and it doesn't change shape or size or anything. So it can still be congruent. So we have three that we're going to go over. So we're going to draw kind of a little table. So we have a transformation. We have a nickname for it. And then we'll give you an example of what one looks like. So the first one is a reflection. And you guys all know what a reflection is when you look in the mirror. Kind of looks the same, only reflected. There's a nickname called the flip. Now this is the word on the street, and we don't use our street language in our math class. But just so you know, it's kind of like flipping it over whatever line they give you. Sometimes you can think of a mirror. But when it asks you for what's the transformation, we're not going to use the word flip. We're going to use reflection. Flip just kind of helps us remember what it looks like if we have to do that transformation. So we're going to draw a triangle on the coordinate plane. And I want 1 point at 1, 1, 1 at 1, 3, and 1 at 3, 1. We will label it A, B, C with A at the right angle. Okay, if we want to do a reflection in the y-axis, that just means flip it over the y-axis. So we do exactly the same distance from the y-axis on the left side. So it's just going to come right here, and then we call it A prime. So once you do a transformation, the vertices will all be labeled with prime. This is called a prime. So B prime would be at -1, 3. So that's the same distance away from the y-axis. The C was out to 3 units, so we're going to put it out to -3 here, and that would be C prime. So there's an example of a reflection. My coordinate plane doesn't look, super awesome, but if you folded the paper right along that line, those two triangles would match up. Yeah.
Can we use actual coordinate planes?
Yes, you could, yes. Oh, you mean for your notes?
Yeah.
If you would like to. Then we have one that's called a translation. This is the one, to me, is harder to remember the word with the example and what it means. The street name is slide. So it's basically you're taking a figure and sliding it. We usually say along a vector. That just means you're sliding it so many to the left, so many down, or whatever. So on the coordinate plane, this time we're not going to do any specific points. We're just going to take a square and we're going to translate it up and to the right. So it should look exactly the same. It's just moved along a straight vector. So like this one just kind of goes that way, or it could go sideways or that way or whatever. The last one that we're going to go over is called a rotation. And that one, the word on the street is turn. It always reminds me of a door handle, like when you turn the door handle. The door handle doesn't change shape or size, it just turns around that little point. So this one, is a little bit harder to describe. So we're going to actually graph points this time. Okay. And then, so you put 7 on the x-axis and then go up. 7. And then go over -5. Okay, so I want you to plot point A at 6, 4. And then point B at 6, 1. And C at 1, 1. And then D at 1, 4. So we just made ourselves a rectangle. Now I want to rotate this 90 degrees, which means counterclockwise. Anytime someone says rotate and they don't tell you clockwise, they don't say anything, it's always counterclockwise. So we're going 90 degrees, and here's what I like to do. I'm going to show you first. I just pick up my book and turn it 90 degrees. Boom. And then I look at where these points are. If you notice, C is at -1, 1. If this becomes the Y and that becomes the X. Do you see how this would be -1, 1? Because you go left 1 and up 1. So C prime is at -1, 1. So I'm just going to go to -1, 1 and write my C prime. And then I'm going to rotate again to find out where's B. B is at -1, 6. -1, 6. So I rotate back. I go -1, go up 6, and that's my B prime. Now I know that A and D are going to be to the left. So D will be 1, 2, 3, 4, -4, 1. So that's D prime, and then A prime will just be straight up from it and across from B. So what we did is we actually rotated it about the origin. If you rotate it about a different point, it kind of changes what it looks like, but for now we're just going to learn that that's a rotation. The whole figure just moved, didn't change size or shape. All of these transformations stay the same size and shape. It's called rigidity. They are isometries. All 3 of these transformations stay the same size and shape. And you can put in parentheses isometries. I don't believe that they introduced that word in your book, but I like to have new words ahead of time. Isometry, I-S-O-M-E-T-R-Y. So when you hear it next year or the year after, you know what it means. One more type of transformation that does not stay the same, does not stay congruent, is called dilation. When you have a dilation, it can either get bigger or smaller. So if we have just a regular right triangle and we keep the same angles but we just make it smaller, we call that a reduction. If this first one's the original, smaller would be a reduction, and if we make it bigger, we say that's an enlargement. Okay, that's the end of the lesson.